Hi everyone, welcome to another video lesson. And in this video lesson, you'll learn how to use the quadratic formula to help you solve quadratic equations. So when a quadratic function or quadratic expression in standard form is not factorable, or if it's factorable, you can always use this formula to help you find the solutions to the equation. Okay, so let's start with example number 1. I'm just going to mention, in this case, since we don't see a value in front of the x squared, that means, and I don't know, let me just write this down before I go into the lesson. So ax squared plus bx plus c, this is the quadratic in standard form. So b, a, and c come from this formula. Okay, so a is the value in front of the x squared, so in this case there is no value, so that means it's an implied 1. So a equals 1. B in this case is -5, so B equals -5, and C is +4. So all I'm going to do is I'm going to plug these values or substitute these values into that formula. Okay, so this is the opposite sign of B. Since B is -5, then this is +5 plus or minus square root of, it says take B and take the square, so B is -5. So -5 squared minus 4 times A is 1, and C is 4. Then this is being multiplied by 2 times the value of A. Okay, so then this is equal to 5 plus or minus square root of -5 squared is 25, minus 4 times 1, that's 4, -4 times 4 is 16. So this is over 2 times 1, which is 2. So then this is equal to, let's see, 5 plus or minus square root of 25 minus 16 is 9. So this is over 2. So then for this one here, let's see, so this is equal to 5 plus or minus square root of 9 is 3 over 2. So here's where we get two solutions. So one is 5 plus 3 over 2. And the other is 5 minus 3 over 2. So this is equal to 5 plus 3 is 8. And 8 divided by 2 is 4. And this one here is 5 minus 3, which is 2. And 2 over 2 is 1. So then the points of intersection of the x-axis are, or zeros, 4, 0. And the other is 1, 0. Okay, so that's the point of the quadratic formula. And let's move on to example number 2. But notice for example number 2, I need to have the equation in standard form. So I'm going to move this 2 to the other side. So then we have 3x squared plus 3x minus 2 equals 0. Again, this is A, this is B, and this is C. So I'm going to plug them into the quadratic formula. So x equals the opposite sign of B, so that means -3 plus or minus square root of B squared is 3 squared minus 4 times A, which is 3, times C, which is -2. Okay, all of this over 2 times A, which in this case is 3. So then once I've substituted, start simplifying. So we have -3 plus or minus square root of, okay, 3 squared is 9, right? And 9, this is -4 times 3, that's -12. -12 times -2, that's +24. So we have 9 plus 24. 9 plus 24 is +33 over 2 times 3, which is 6. Okay, so in this case, notice that I am not going to separate these two. I'm just going to leave it like this. And this is called the simplest radical form. Okay, since the number is positive on lesson 9.3, this implies that we have two real solutions. Okay, so this means we have two real number solutions because that number inside the radical is positive. So I'll just say that here. And also this is the simplest radical form because 33 is prime. We can't, the only multiples of 33 are 3 and 11, but we can't take anything out of the radical. So this will be the simplest radical form. and I did a double C there. So simplest radical form. And that's also, this has two solutions. One is the plus and the other one is the minus. Okay. All right. Number 3, I'm going to jump this negative x squared to the other side so that it becomes positive. Then I'm going to rearrange it so that that is written in standard form. So that then this is positive x squared minus 6x plus 9 is equal to 0. So A is 1, B is negative 6, and C is 9. So then x equals, so for this one, opposite sign of b, which is negative 6, so becomes positive 6 plus or minus square root of b squared, which is negative 6 squared minus 4 times a is 1, and c is 9. All of this over 2 times a, which again is 1. So then for this one here, notice we have negative 6 squared, which is 36. But the negative 4 times 1 is negative 4. Negative 4 times 9 is negative 36. So we end up with 36 minus 36 over, and we have 6 plus, right? So 6 plus or minus that. All of this over 2 times 1, which is 2. So then, as you can see, inside of the radical, that's going to simplify. So then this is 6 plus or minus square root of 0, which means the discriminant is 0. So if that is the case, then this just simplifies to 6 over 2. Okay, plus or minus doesn't matter because it's still going to be 0. So then this is 3. So then the solutions for this one are 3, comma, 0, but we only have 1, which means this has to be a double solution. And that's all for this example. All right, next one, the last example. I'm going to notice that A is 1. So this is 1, that's the value of A. This is B, and this is C. So x equals the opposite sign of b, so that's 3, so negative 3 plus or minus square root of b squared, which is 3 squared, minus 4 times a, which is 1, times c, which is 8. All of this over 2 times 1, which again is 1. So then this is negative 3 plus or minus square root of, this is 3 squared, which is 9, negative 4 times 1 is negative 4, negative 4 times 8 is negative 32. All of this over 2, with 2 times 1, which is 1. But then notice, when we simplify this further, so negative 3 plus or minus square root of 9 minus 32, that's a negative 23. And also notice that this one here, this is less than 0, so this is imaginary. Okay, so this one has 2 imaginary solutions. So these are not real numbers. So then I'm just going to leave it like this. I'm going to say, all I'm going to do is take out the negative, right? Because if I have the square root of negative 23, all I can do is separate the negative 1 and then multiply that times positive 23. But then don't forget, if you have the negative 1 inside of the radical, the square root of negative 1 is equal to the number I. Okay, so that's all I'm going to do here. So then x equals negative 3 plus or minus I, because of that negative 1, square root of positive 23. 23 is prime, and then divide this by 2. And again, this one has 2 solutions, but they are both imaginary, which means this parabola shouldn't be crossing or won't be crossing the x-axis. And thank you for watching. Bye-bye.